All right, let's get into it. Today, we're going to lay out a clear roadmap to mastering one of the most powerful and influential programming languages ever created, the C language. And look, it's a totally fair question, right? We've got all these slick, modern languages. So why on earth would you spend your time on a language that's been around for half a century? And that right there is the answer. C isn't just about writing code. It's about really understanding the machine. It gives you the power to get your hands dirty, to work directly with memory, and to really grasp the core principles that pretty much all of modern computing is built on. Okay, so let's really dig into that idea. Because C isn't old, it's foundational. It's the language that literally built the digital world we're all living in. And trust me, its fingerprints are everywhere. See, when you're learning C, you're not just memorizing syntax. You're actually learning the how and why behind the tech that powers our world. We're talking about everything from the operating system on your laptop to the software in your car to the massive servers that keep the internet running. C is humming away in the background of it all. And you just can't argue with its dominance in these critical fields. The very core of Windows and Linux, that's C. The tiny, efficient code running in your smart thermostat, C again. Those blockbuster video games with stunning graphics, you guessed it, their engines rely on C for its raw speed and absolute control. All right, so every mastery journey has to start at square one. And for C, that means learning the universal grammar of programming itself. So these are your non-negotiables, the absolute basics. You can think of variables as little boxes for your data, operators as the tools you use to change what's in those boxes, and control flow, your if-elses and loops, as the traffic signals that direct the entire flow of your program. Now, this is super important to get. Your C code doesn't just run. It goes through this four-step translation process. First, the preprocessor gets everything ready. Then, the compiler turns your code into a lower-level language called assembly. The assembler takes that and creates machine code the computer can almost understand. And finally, the linker pulls it all together with any other code it needs to create the final runnable program. Okay, now we're getting to the real heart of it. This is what separates C from the pack. This is the moment you go from just being a coder to becoming a true systems programmer. Most modern languages have this safety net called a garbage collector that automatically cleans up memory for you. Well, C doesn't have that. It just hands you the keys to the car and says, you're in charge. And that's an immense power. It's why things like game engines use C. They need to control exactly when and how memory is used to get that buttery smooth performance. And pointers, they are the tool for this control. This is maybe the most crucial concept in all of C. A pointer doesn't hold a piece of data itself, it holds the address of that data. Getting your head around this is the key that unlocks absolutely everything else. So think of your program's memory like a workspace with two main areas. You've got the stack, which is super fast, automatically managed, but kind of small. It's perfect for temporary variables inside a function. Then you have the heap. It's a huge open space that you get to manage yourself. This is where you put the big stuff, the data that needs to stick around for a while. And to work with that heap memory, C gives you this essential toolkit. You use functions like malloc to ask for a chunk of memory. You can use realloc if you need to change its size. But, and this is the big one, when you're done with it, you are responsible for giving it back to the system using free. If you forget, you create what's called a memory leak, and that's a classic C programming bug. Okay, so once you've got a handle on memory, you can start thinking bigger. We're moving from just managing data to actually architecting large, complex systems. Right, so if you think of basic variables as individual bricks, a struct is like the architect's blueprint for a whole room or even a whole building. It lets you bundle different types of data together, like a person's name, age, and height, into one clean, logical package. This is how you build real-world data models in C. And let's be real, you can't just dump thousands of lines of code into one massive file. It's just not going to work. Professional C code is all about being modular. You have header files that are like a public menu, saying what a piece of code can do, and then you have the source files, which are like the kitchen, containing the secret recipe for how it gets done. So here's the cool part. Before your code even hits the compiler, this little build assistant, the preprocessor, goes to work.
It pulls in code from those header files, it swaps out shortcuts you've defined, and it can even include or ignore entire blocks of code depending on the situation. It's an incredibly powerful way to manage complexity.
And that brings us right up to the modern day, the final stage of our path to mastery. See, mastering C isn't just about the old school stuff. It's about using the modern tools that keep the language sharp and relevant. What this really shows is that C is not some dusty relic. It's a living, breathing language that's actively maintained. The latest standard, C23, is especially exciting because it brought in some fantastic upgrades for both safety and just plain convenience. This is a perfect example of how C is getting smarter and safer. For ages, we used null to represent an empty pointer, but null was really just a fancy name for the number 0, which could cause some tricky bugs. C23 introduced null pointer, which is an actual, dedicated keyword. The compiler knows it's a pointer, not an integer, which makes your code safer and a whole lot clearer. And it doesn't stop there. C23 brought in a bunch of other really nice upgrades. You can finally write numbers in binary directly, which is amazing for low-level work, and you can add separators in long numbers so you don't go cross-eyed counting zeros in 1 million. These are quality-of-life changes that just make modern C development better. So when you put it all together, what does mastery in C really mean? It's not just one thing. It's this powerful combination of understanding the hardware, having total control over memory, knowing how to design clean systems, and then using all the modern best practices to write code that's not just fast, but also safe and reliable.
So there you have it. We've mapped out the whole journey, from laying the first foundation block to building a modern skyscraper. The blueprints are in your hands. The real question is, are you ready to start building?